Hello. Today's video lesson is going to focus on functions as equations. So prior to today we were working with functions as graphs, and we would utilize this graph to answer a variety of different questions about the function. We would also look at tables. If we have a table of values, we can use the table of values to answer the same kinds of questions. So what makes today's lesson different is instead of using graphs or a table to answer our question, we can use an equation to do the same thing. There's pros and cons to each approach. It all depends on the situation that you're dealing with. Sometimes equations are better to work with, and sometimes graphs are better to work with, and sometimes tables are better to work with. It all depends. So we need to become skillful at working with each of these representations. So first, a quick review on the notation. We start with this function, so we have a context, so we know what we're talking about here. X represents the number of blankets that this company is going to be producing in a day. P of X represents the profits they make, which depend on the number of blankets. So if I change the number of blankets I make in a day, it will change the amount of profit that I make. So the two questions we have here are evaluate and solve. Evaluate questions will give you a value for the independent variable. In this case, they'll give you the number of blankets, and your job is to figure out what profits would emerge. Conversely, if I ask a solve question, I tell you how many profits I want. I want $52 in profit, and I'm going to ask the equation, how many blankets should I make? So one question, we give you the independent variable, you need to give us the dependent, and then the other kind of question, just invert that. So how would we answer these questions since what we're given is an equation rather than a table or a graph? Simply enough, all we have to do is, wherever there was an x, we replace it with 3. Then we're going to do the evaluations here, and I'll work through the order of operations and all that later. But for right now, we just make the observation that once you do all the calculations on the right-hand side, you get $18.25. So we can now translate that if they made 3 blankets, they'll make about 18.25 profit. That's after all their costs have been covered. Here, this is a little different. Now I've taken the y value, p of x, and replaced it with 52. So what I have to do here is actually solve this equation to find the number of blankets that need to be made to get 52. In this case, incidentally, there are actually 2 different solutions. So we can get $52 in profit making 8 blankets or 12 blankets. Completely our choice. Anyway, what I'd like to show you is how I'd like to see the notation written out when you do this kind of work. So I'm going to show you in typed form. Here is another function. This time it's the height of an object at time t. So there's this object that's being like knocked about or something, and if I want to know how high the object is in the air at any given time, I just have to put in the time for t, and it will tell me, what the height is. So for example, h of 4, in order to find the value h of 4, I just substitute the 4 in for t in both places where it occurs. Notice the use of parentheses, that's a requirement. And I end up with 152 meters. So h of 4 is asking, how high is the object after 4 seconds? The answer is 152 meters. H of 10, how high is the object after 10 seconds? The answer, 980 meters. Finally, the last question is a solve question. If h of t equals 20, what is t? A better translation of that would be, how long does it take for the object to reach 20 meters in the air? Again, h of t is the y value, so to answer that question, I replace the y value with 20, and then I'll solve if I knew how. So, study this page for a little while because it's going to show you, again, how the notation is supposed to look, but I'll show you again in the following examples. Sometimes the function we're dealing with has no context at all, and that's fine. The rules are still the same. So here I'm asked to find f of negative 4. So what do? All I have to do is substitute negative 4 everywhere I see an x in the equation. Then notice again the parentheses. See, now this is not 3 minus 4, it's 3 times negative 4. Without those parentheses, it would be really tough to see that it's a multiplication exercise. 3 times negative 4 is negative 12, plus 20 equals positive 8. Now, there's no context here, so I can't talk about heights and time, and I can't talk about blankets and profits, but what I can talk about is equations and solutions. Negative 4 is the x value, when 8 is the y value, so negative 4, 8 is a solution to the f of x equation. So it's worth just reminding yourself. This is sort of a mantra. You want you to repeat it several times until you get the hang of it, that when you substitute a value in for x and get a y, you're getting a solution to the given equation. Part B is asking us to find f of 10 Easy enough. Instead of putting in, substituting in -4, I substitute a 10 for x. Notice again the parentheses. The rest is arithmetic. Part C says if f of x equals 38, find x. Well, I can do that. First, I repeat the mantra. 1050 is a solution to the f of x equation. Finally, to get part C, I'm going to replace f of x with 38 and solve for x. This is algebra 1 kind of stuff. And so here, I have 638 as a solution to the equation because f of 6 equals 38. That's all there is to it. Now there's more stuff that we're going to learn about how to check your answer and do all this stuff, but today I would like us to focus on two things: the arithmetic skills of evaluating on the right hand side and the skill of substitution with proper notation, use of parentheses. So for another example, we're going to look at context this time, so our answers are going to look a little different because they should be in a context. But here again, what we have is the height of an object is a function of time. Asking for h of 2 is asking how high was the object after 2 seconds. So everywhere I see a t, I replace it with 2, and that happens twice, here and here. So my eyes are trained everywhere I see parentheses to know that that's where the variable was supposed to be. Everything in parentheses has been a replacement. Notice here that I square the 2 first and then multiply by 4.9. That's an order of operations issue. We do the exponents before we multiply. First mistake everybody makes in Algebra 2, they multiply the 4.9 by 2 and then square the result. And if you do that, you will be wrong. Anyway, this final answer says that after 2 seconds, the object will be 80.4 feet up in the air. So 2, 80.4 is a solution to the equation. H of 5, same thing, except now 5 appears in 2 different places. We square first and then multiply, and we get our result. Quick little answer in context. We're good to go. Finally, if h of t equals 0. Now this, I'm just showing you to remind you that we have an equation now to solve. Some of you may remember how to solve this equation, some of you may not. The easiest way is to factor a t out of the equation and do this thing called the zero product rule. I'm not concerned with the algebra right now. That doesn't really matter. What does matter is that you understand that if you're asked to find h of t equals 0, you're really asking to find what time will it take for the object to reach a height of 0, and we have to set up the equation this way and hopefully learn the algebra skills to solve it. Finally, a voltage question. The reason I put this up here is because t, the variable, exists in 2 different ways. There's a regular number being multiplied by 3, and then there's also a variable exponent, which is the same t. So just to make sure that we're aware of how to work with exponents, I wanted to use this example. So V of 4 is asking for the voltage after 4 seconds. So notice, oh, and I committed a little crime here. This should be in parentheses right there, because both t values, one here and one here, have been replaced by 4. I had to go to the calculator to figure out what this is, but that's not a crime. I get 10.92 seconds after, volts after 4 seconds. So here's another math crime. I used the wrong label. All right. Moving on, though. In 4 seconds, I answer in context. This is the last thing I wanted to mention. You don't even have to know what the number is for time. The number can be expressed in what's called general terms. So I don't know what c is, but I want time to be whatever c is plus 10 more. So that says find the voltage after c plus 10 seconds. The goal here is to learn how to treat c plus 10 just like any other number, just like 5, just like 17, just like pi. C plus 10 is a number. It just happens to be unknown at the moment. But to evaluate, just like before, where I saw a t, I replace it with c plus 10. 1.02 used to be to the t power, now it'll be to the c plus 10 power. A lot of times students will want to say, well, I need to do some simplifying now because this is too easy. Yes, it is too easy. The only thing we can do to this with our available tools is to distribute the 3. So we'll get 3c plus 30 minus 1.02 to the c plus 10 power. There really is nothing much I can do right now to make this any simpler than it is. So the goal here is not to work about on our algebra. The goal here is specifically to understand that the rules for evaluating functions applies whether the number we're using for the variable is known, like 4, or whether the number we're using for the variable is unknown, like c plus 10. Anyway, thanks for watching. I have a series of exercises that I would like you to do to get started, and the goal for these exercises will be strictly just master the notation, get perfect at the notation. Thank you.